Welcome to solverfy.
Here the question is, the following table indicates the number of unpaired electrons in the crystal field diagrams for some complexes. Complete the table by classifying each species as weak ligand, weak field, or strong field, or insufficient information. So in the first case, that is the complex given is iron complex with CNS, first one, and here iron is at +2 oxidation state. So its electronic configuration should be Ar, 4s0, and 3d6. Now here it is given that unpaired electrons are 0. That means all the 6 electrons are paired. That is possible only when splitting of the orbital is more. That means splitting energy is high. This is high only when the ligand is strong field ligand. So here it should be strong field ligand. And in the second case, cobalt complex is given and coordination number is 4. So cobalt is also at +2 oxidation state. When it is at +2 oxidation state, its electronic configuration is Ar, then 4s0, 3d7. 7 electrons are present in d orbitals, and it is given then 3 are unpaired. 3 electrons are unpaired. So this is possible only when splitting is less. Splitting is less. When splitting is less, then the electrons are filled first singly, 3, 4, 5, and then only pairing is taking place, 6 and 7. And by this it is quite clear that 3 unpaired electrons are present. Now, when 3 unpaired electrons are present, and this is only possible when the splitting is less, and this is again possible when the ligands are weak field ligand. So here it should be weak field. Now come to the next one, that is the third one. This is iron complex with the water, and here 5 unpaired electrons are present. Iron is here at +3 oxidation state, and its electronic configuration should be Ar, nearest noble gas configuration, then 4s0 and 3d5. 1 electron is removed from the d orbital. 5 electrons are present in the d orbital, and here in the question it is given that 5 unpaired electrons. That means all the electrons are present which are unpaired. So this is only possible when the splitting is very less, and the ligand is weak. So in this case, electrons are first filled singly and then only pairing is taking place. So by this we can explain very well that how 5 unpaired electrons are present in it, because the splitting is less, and this less splitting is possible only when the ligands are weak. So here the answer should be weak. And in the fourth case, complex is again iron, complex with the CNS, and number of unpaired electrons are given 0. So here iron is at +2 oxidation state. That means its electronic configuration is Ar. Electrons are removed from 4s orbital first, then from 3d. So 6 electrons must be present here. And 0 unpaired electron is indicating very clearly that the splitting is more. That means difference between this lower energy level and upper energy d orbital should be more. When this is the case, then electrons are first filled here in the lower orbital singly, and then only pairing is taking place here, and no electron is going up. So all paired electrons can be explained by this only. And when the splitting is high, this is only possible when the ligands are strong. So strong filled complex is formed here. In the last complex, iron with Cn.